Well, hello there, and welcome to this video on advanced techniques for Elgato Game Capture. If, like me, you're an owner of an Elgato product, then you may have already witnessed how easy it is to get set up and start recording your gameplay. But for me, the problems start when I need to do something with that gameplay footage. It was awfully thoughtful of Elgato to add their own little editing section on the software, but in my opinion, this falls short by a long shot, because not only is the editor very limited, but the actual export process takes an absolute ice age. I can literally feel the hairs growing on my head while I'm waiting for this export process to finish. What's actually happening here is it's turning the variable frame rate footage into constant frame rate footage, and it's doing so with a variable bitrate, which is a shame because you can actually lose quality during this process. So not only is this software wasting my time, it's actually making the quality worse. I don't blame Elgato for this because their capture cards are not really aimed at people like me. They're aimed more at people who want to record some simple console footage and make a short highlight for YouTube. In that scenario, the editor is just fine. But say you wanted to cut up several segments and then import it into a software such as Sony Vegas, or Magix Vegas if you've got the newer version. But doesn't this mean that we're encoding the footage when we first record it, then encoding the footage again when we export from Game Capture, encoding once more when we export a final master from our video editor, and then again when YouTube receives that final footage? And potentially that's 4 encoding passes, 2 of which we can't even control. If you're the inquisitive type, then you may have already noticed that the files recorded by Game Capture are actually playable by most media players. It's just that they're very difficult to work with when using a video editing suite. And as mentioned before, the files recorded with Elgato Game Capture are actually variable frame rate, which doesn't really sit well with constant frame rate video. The same is true for any other software that records game footage, because when you're playing a game, the frame rate is never at a solid 60 or a solid 30 or whatever your maximum frame rate may be. Even a perfectly coded and massively optimized game would still show frame rate variance in certain sections, depending on what's happening in-game and on the computer. And while some editing software is able to work with variable frame rate, I've found that the final rendered footage does not look as good as it should, so transcoding to constant frame rate is absolutely necessary. So really, I've just wasted your time listening to this. Or have I? What if there was another way to chop up the footage and then transcode using the settings that you want to use, rather than the settings that are pre-programmed by a game capture software? If we had control over the bitrate and the quality options of the transcoding, then there would be no visible loss of quality, which is very important given how heavily compressed these files are. 60 megabit at 60 frames a second 1080p might sound like a lot, but really it's not at all. From an editor's standpoint, at least. So before we get into the nuts and bolts of this tutorial video, let me share with you the setup that I run. I use an i7 4790K clocked at 4.4 GHz on turbo, which is great for most things, but unfortunately when recording game footage at 1080p 60 frames a second, there's noticeable strain on the computer. It doesn't seem to matter which codec I use or which recording software is actually doing the recording. There's this horrible feeling of frame loss when the frame rate counter might just say 60 frames, and I think, what's going on? It wasn't too big of an issue at first, but eventually I did notice it, and once you notice something like that, you can't unnotice it. After a while, I started using OBS Classic and OBS Studio with the QuickSync support. QuickSync is something that's available on the higher class Intel CPUs, and it basically means that there is an integrated graphics processor built into the CPU, which would normally be used in a system that has no graphics card, to display the desktop. One nice feature of this integrated graphics processor is its ability to encode 264 video separate from the main processor. Of course, most gamers have dedicated graphics cards, so this integrated one often goes unused, which is great because then it's available for game capture software. And most game capture software does have support for this by now. And by using QuickSync, you can go from 20% of your processor unavailable to only 3, 4, or maybe 5% unavailable. And here's the best bit, you can't see the game stuttering anymore. Sounds great, doesn't it? And it is great until you watch the footage back in your video editor and notice that there's a problem with it. I've no idea why, but every couple of seconds in OBS Studio, XSplit, whatever software I'm using, I can see a noticeable I don't know what it is, to be honest. It's like a stuttering, but it's not in the game, it's only in the recording. It's like a hitch. And from what I've gathered by user feedback on forums, is it's something to do with the frame rate versus the refresh rate of the monitor. But I'm not entirely convinced that's the issue at all. But QuickSync is definitely a highly regarded tool when working with high bitrate footage. NVIDIA graphics card have their own encoder built in called NVENC, which is what Shadowplay uses. AMD graphics cards also have their own dedicated encoding chip, referred to as VCE or AMF in the later drivers, which I think is the same thing that Relive is using. Now, I'm an AMD graphics card user myself, so I can't really comment on NVENC or Shadowplay, but I have heard good things in that the quality is right up there now, whereas AMD encoding is slightly lacking a bit in my experience. But to be perfectly honest, if there was another way besides the integrated processors or the encoding chips, I would rather pick that. Because as nice as things might work, I'm a firm believer in that every part should have its own use. You shouldn't really be trying to share several processors with one device. Let that device do what it needs to do and let another device do whatever it needs to do. You know, if you actually care about what you're doing. And I do. There's nothing worse than capturing some great footage, editing it into a video, uploading it to YouTube, and then noticing the video is not as good quality as it could have been. That really winds me up. With the amount of effort that I put into making my videos, I just feel like maybe I've wasted my time. Because maybe the person watching the video sees the same thing I do. Maybe they don't, but you know, for me it's room for improvement, and if I'm not improving when I can improve, then I'm not pushing hard enough. So I realise I've been talking for a while now, and you're probably wondering what's the point of all this? Well, I was leading up to the fact that the only way that I could possibly remove all of the frame drops and the weird artifacts caused by recording with software encoders or integrated 264 encoders, sadly, was to buy a capture card. But to be fair, I don't regret purchasing the Elgato HD60 Pro. It's a great piece of hardware, and you can tell that the software has been designed so that anybody can use it. But what's a plus point for some is actually a minus point for others. Because I've seen people say if you want control over the Elgato capture card, you have to use OBS. But what if OBS isn't working for you? Well, in my case, I had to come up with my own workflow, which I'm sharing with you today. So first of all, let me just mention that I also have the issue that a lot of other people have where the Elgato won't capture the microphone properly without clicks and pops. Now, I don't know whether this is just an issue in older software or whether it's fixed yet or whether it will be fixed, but I've always recorded audio separately anyway, even when I used to use OBS Classic, because there was a time where I didn't have free software that had multi-channel audio capabilities. And I'm the type of person that if it doesn't exist, then I make it myself. And so I did. I made my own software called Multi-Track Recorder, which can record up to 8 channels of audio using various different codecs, although the codec I prefer is OGG Vorbis, because it's as good as, or better than AAC. It requires no license to use and is open source. It's well supported on various media players and operating systems, and it can record for long periods with no problems. If you're interested in trying it out, it's a free software, so go to my website and download it. So what I'd normally do is have several virtual audio cables, one for the desktop audio, one for my microphone, and one for voice over IP, such as TeamSpeak or Discord. I record all 3 at once to separate files with multi-track recorder, then I start capturing the game footage. When I'm finished, I'd stop both the game capture and the multi-track recorder. Both the video captured with the game capture software and the audio files captured with multi-track recorder use the date and time in the file name, which I'd then use to find a rough synchronization between the two. I would finally use the visual representation of the audio, the waveform, to synchronize all 3 audio files with the audio from the video. I can understand if you think this is a very long-winded approach, because it is, but it offers the most flexibility and the most overall control. Thankfully, when you record with the Elgato Game Capture software, it records each audio source into its own separate channel. The only problem is that the Game Capture software supports up to 12 channels of audio, and every recording has 12 channels of audio. So let's say channel 1 was your game audio, channel 2 was your microphone audio, channel 3 was your voice over IP, TeamSpeak or Discord, and then channel 4 is a stereo mix of all 3 channels for use in media players. That leaves 8 channels unused, so if you recorded for an hour, you'd have 8 channels with an hour's worth of silence. It might not sound like much, but when you strip away those channels, that's several gigabytes on your hard drive. And if you study the channel layout, you'll see that some channels are just duplicated, so what's the point of that? Well, I don't know, I can only speculate it's something to do with surround sound and it's just unused in a stereo mix. I really don't know. So what have we identified so far? The editor section of the Game Capture software is nowhere near good enough for video editing. The transcoding is potentially throwing away some quality. The audio from certain sources is perhaps not as good as it could be. And the master files are storing way too much audio information, more than we need. Of course, all of these things can be fixed, but as the video title suggests, we need to use some advanced techniques. So the main piece of software you're going to need for this is called FFmpeg. You'll want to grab the 64-bit static build of FFmpeg for Windows. The 64-bit edition is much more efficient at encoding versus the 32-bit edition, which encodes at slightly fewer frames per second. Unfortunately, when I tested, the 64-bit edition of FFmpeg was not capable of frame serving, but we won't be doing any of that today, so it's not an issue. Anyway, I'm going to assume at this point that you won't be using my multi-track recorder to record your audio. You'll be using Elgato Game Capture's built-in AAC recordings, and hopefully you don't have any problems with the microphone, or you're using the sound capture to fix that problem. So let's say you'd been recording for an hour and there was 10 minutes of footage that you wanted, smack bang in the middle of this file. Normally you'd go over to the editing tab in the Game Capture software, you'd chop the start and the end points and then export the footage. Forget about that. What we're going to do is use an FFmpeg batch script to place the video and audio into a new container. A container is just a file that holds many other files and then specifies a way in which they should be used together. The files recorded with Elgato Game Capture are already in a container of sorts, but it's not really a very editor-friendly container, as you would have seen if you've ever tried to load it into an editor. So this process of changing the container is referred to as remuxing, R-E-M-U-X. Now the beautiful thing about remuxing a file with FFmpeg is that you can choose which streams you want to copy over. So remember I was saying earlier about the files recorded with Game Capture having 12 audio streams? Well, in this single step we can change the container format and also discard any audio streams that we don't require. Now it would be foolish for me to assume that everybody that uses Game Capture has their computer set up in the exact same way that I do, and therefore wants to copy the exact same audio streams that I do. I recommend that you do a short recording that features all of the audio streams that you'll be wanting to capture. To figure out which audio streams are the ones we want to save, we can use a batch with FFmpeg. So start off by making a new folder on your C drive called FFmpeg. Take the 64-bit edition of ffmpeg.exe and drop that into the new folder that you've just created. Also download the batch file package from the video description. There are several useful batch files in this package, but the one we'll be using right now is called adts_dump. If you take a quick look inside this batch file, you'll see that all it does is save every single stream to a separate file, which would give you the opportunity to check each individual stream and figure out which ones you need to keep. Doing this is very simple. If you navigate to your Elgato library folder, find your test recording, then drag and drop the .ts file onto the batch file. Once it finishes, you should have 12 extra files, all AAC audio, each with the channel ID number as part of the file name. So right now, my channel setup is as follows. Channel 0 is the game sound. Channel 2 is my microphone and voice over IP, TeamSpeak or Discord. Channel 4 is the stereo mix. What I want from a remux is for those channels to be put on channel 0, 1 and 2, and then discard everything else. So channel 4 will become channel 0 will become channel 1, channel 2 will become channel 2, resulting in 3 audio streams instead of 12 audio streams. I'm keeping the stereo mix as the first channel because when using media players and other editing software, you want a point of reference for chopping the start and end of video footage. Because if I would have copied game sound to channel 0, and then microphone and VoIP to channel 1, we would never hear the VoIP while previewing, potentially missing important moments. You'll most likely need to change this channel setup to the way yours is set up. As I said, do a test recording first and see where the channels are in the channel layout. Maybe you are using the same setup as I am, so maybe this is the setup that you need. but you'll need to check first because if your pizza when you were supposed to French fry, you're gonna have a bad time. Now you need the batch file which contains the remuxing code for FFmpeg. Here's the one I use, and I'm going to explain exactly what it does. It starts off with a for loop that accepts a single or multiple files that can be dragged and dropped directly onto the batch file. It passes each file to FFmpeg with a starting option to hide a lot of the junk you don't need to see. Then it accepts the input file, followed by a bunch of map directives, each using the copy option, and finally a bitstream filter to convert the ADTS, Audio Data Transport Stream, to ASC, Audio Specific Config. Each FFmpeg batch must end with a file name. In this case, we're using the original file name plus.mp4. The for loop ends, and then there is a pause to let you know that processing is finished or something went wrong. You'll have to press a key to end the batch. I would imagine that if it's your first time hearing about FFmpeg and batch files, then you will have probably understood everything except the map directives. So let's take a closer look at those now, shall we? The first map directive targets file 0, video stream 0, with the codec set to direct copy. The second map directive targets file 0, audio stream 4, with the codec set to direct copy. The third map directive targets file 0, audio stream 0, with the codec set to direct copy. The fourth map directive targets file 0, audio stream 2, with the codec set to direct copy. So the channels are copied in the order that we would like them to be saved. Okay, let's now remux the file. This process can take quite some time to complete, especially if your files are large. When the batch ends, you should now have a copy of the file that you originally dropped on, with .mp4 appended to the file name. You'll probably also notice that this new file is somewhat smaller than the original. That's because we've discarded any channels that we won't be using. If you try to drop this new file into any editing suite, you'll also notice that it goes in quite smoothly. But we're not quite ready for editing just yet. As I said earlier, if you had an hour's worth of footage and you wanted 10 minutes from the center of the file, you would have to further chop this file before editing it. To do this, we use another great free software called Avidemux. So go ahead and download the 64-bit edition of Avidemux, install it and then open it. You should see a window similar to this one. Drag and drop your new .mp4 file onto Avidemux window. It should load your file in ready for editing. If you have a long recording, it might take a couple of seconds before showing up. Just give it a few moments. Okay, so we're going to get slightly technical once again, just so you understand what's happening. The H264 encoding standard contains several different frame types. One of those being intraframes, or iframes for short. These iframes contain a reference to the image on the screen, which future frames will use as a base to create the imagery. This means that not every frame of video has to contain the full amount of pixels shown on screen. Future frames can contain only parts of what the user sees on the screen, and the rest is borrowed from the iframe. So with some frames only needing some information, we can achieve much better compression. The iframe can be used as a splitting point. Everything before the iframe could be discarded, or everything after the iframe could be discarded. So this means we can set start and end points and then just chop out the footage we want. If you scrub through the footage using the little bar and find the section that you want to start on, then if you press up or down on your keyboard, or double left, double right button on the control bar, it should scrub through using only iframes, or keyframes as it calls them. You can verify this by looking underneath the controls. Where it says frame type, it should say I-FRM for iframes. When you found the position where your footage begins, press Ctrl and page up, or press the A button on the control bar. Now do the same again for the end of your footage. Scrub through using the little bar and find where your footage ends. As before, use up and down on the keyboard, or double left, double right on the control bar to scrub using iframes. When you've located a suitable endpoint, press Ctrl and page down, or press the B button on the control bar to set your endpoint. Once you've done this, you should see that the portion in between the start and end point has now been highlighted into its own segment. You can press page up to go directly to the start point, and page down to go directly to the end point. It's worth doing a final check to make sure that both points are set on iframes, because if you don't start and end on an iframe, it will actually re-encode the footage, and we don't want that. So you should be ready to save now. If you look on the left hand side where it says video output, make sure that is set to copy. On the audio output, make sure that is also set to copy. It should also show you how many audio streams are in the layout. And finally, where it says output format, change that to MP4 V2 Muxa. Go to File menu and Save, or press Ctrl and S. Choose a location to save, and pick an appropriate file name, preferably one that reflects the original file, and possibly the offset of where you've chopped. Congratulations, you have now chopped a segment of footage without transcoding. Once you've done this a few times, you'll realise that this is the superior way to record and chop footage with Elgato Game Capture. And if you're doing long recordings rather than flashback recordings, you'll most likely record in smaller segments of half an hour to an hour to 2 hours, and not 6 hours, which could become quite frustrating to process. Although to each their own. I personally stop the recording after an hour, then I wait for a moment for the Game Capture software to finalise the file, then finally start a new recording. Remuxing the files and then chopping out the bits I want saves hard drive space later on, because you have to remember that in order to remux you must have the same amount of hard drive space available as the size of the file itself. Smaller files makes this easier, and you can start archiving your clips right away. So, before we can edit, we need to turn the variable frame rate file into a constant frame rate file. Once again, we'll be using an FFMPEG batch file. As before, it starts with a for loop that accepts a single or multiple files that are dragged and dropped onto the batch. We load the current file into FFmpeg, with the Y option to always overwrite, just in case you tried this before and failed for whatever reason. We specify the codec for video as libx264 using the medium preset, then the profile for video as baseline. We could use main or high, but baseline is easier to edit with. And believe me, I've tried and tested this, there is no difference, so don't worry about the quality. The codec for audio is set to AAC, and the bitrate for the audio is 224K, just like the original recording. You're probably wondering again about quality loss. It's really not a concern, because AAC is good quality to begin with when it's high bitrate, so if you re-encode at the same high bitrate, there's very little chance that you're going to be able to tell the difference. If you can tell the difference, or it's an issue for you, then just simply use a higher bitrate. We're going to set the map directive to 0. Then we're going to apply some manual X264 options. The first of which is Force CFR, where the CFR stands for constant frame rate. We'll be setting the frame rate to 59.94. If you weren't using 60 FPS mode on Elgato Game Capture, change this to 29.97. The colour primary, transfer and colour matrix are all set to BT709, and the full range is set to off. You can find out all of the colour range information by using a tool called MediaInfo. It shows critical information such as whether the frame rate mode is variable or constant. It also shows you the frame rate, and if it's a variable frame rate file, the minimum and maximum frame rate, as well as the colour range, primaries, transfer and matrix information, which may vary depending on monitor and Elgato Game Capture settings. So, the variable bitrate, max rate and buffer size are both set to whatever bitrate you want them to be, in this case 14,000 for 14 megabit. The CRF, QComp, QPmin, QPmax, QPstep, CRF max are all default values. These are just here to override whatever FFmpeg decides to use. The key-in is set to 15. Now the key-in is the keyframe interval, which is related to the iframe. In this case I'm recording in 60 FPS, so 15 is 1/4 of a second if 1 second is 60 frames. And as discussed, the more iframes in a video, the better quality it should theoretically be, and thus less quality loss from transcoding. I've not tested, but if you're transcoding a 30 FPS video, you could probably set this to 6 or 7. The minimum key-in is set to 1. We then set the rate option to 59.94, or if you're doing a 30 FPS video, you can set that to 29.97. And finally, the output file, which again will have .mp4 appended to the file name. The for loop ends, and then the batch file pauses to let you know it's finished, or if there's been an error. You'll have to press a key to end the batch file. So if you grab the file that you chopped in Avidemux, then drag and drop it onto this batch file, you should see it processing, much like it did before when you were remuxing the original file, although transcoding will take much longer, and depending on your setup you may only be transcoding at a quarter of the frame rate or maybe less. And this is the reason that the batch is set up with a for loop, so that you can drag and drop several files on it and just leave it to do what it does, rather than having to do each file separately. When the file finishes processing, you shouldn't see any difference, but if you look at the file with a tool such as MediaInfo, you'll see that there clearly is a difference. The bitrate will be slightly higher than Elgato Game Capture ever would have used, and just like the Elgato Game Capture transcoding, it should now be a constant frame rate. So now, you're ready to edit. I know that's a long process, but when you consider how flexible this is, there's no going back to Elgato Game Capture after you've done this. You can probably see the similarities between the editor on Elgato Game Capture and the editor in Avidemux. So I suppose in a way it's a good stepping stone, because you can't rely on software to make decisions for you. You may have noticed in the transcode script that I've included in the batch file download, there are 6 bitrate levels. 14 megabits for retro games, 20 megabits for retro games with flashy effects, 30 megabits for slightly more complicated graphics like Minecraft, 40 megabits for slower paced 3D games, 50 megabits for better looking games, and finally 60 megabits for nice looking games with high motion. Now, although there is a profile system in the Elgato software, it doesn't work properly for me. I set the bitrate and it just seems to pick a random bitrate, so I ended up swapping it out manually from the config file. As I started recording different types of game footage, I started changing this value more and more. So, I made a small console application in Visual Studio, which will take a simple input from a batch file and then modify the bitrate value in the configuration file. So now, instead of fighting with the slider or trying to get the profile to set correctly, all you need to do is launch a batch file and select your desired bitrate from a menu, and voila, in seconds your bitrate is changed. Of course, I wouldn't tease you about this and just talk about it. It is in fact in the download package in the description, so you too can have this nice bitrate selection. Just remember, don't have the Elgato Game Capture software open when you use the batch file. Do it before you open the Game Capture software. So I think that just about wraps this video up. Hopefully you've learned a thing or two and you find it helpful. If you did, and you do, then consider giving the video a thumbs up. And also consider subscribing, because there'll be more videos in the future. If you'd like to see an example of videos that were created using this method, then go to my main YouTube channel, link is in the description. I'm accepting feedback and answering questions in the comment section below, so feel free to drop me a line. The majority of information and techniques in this video have been gathered and created over the space of several months, with some of the information going back several years. As a musician, programmer, gamer, designer, and a whole bunch of other things, I have quite a lot of experience on computers. I understand how hard it is to learn some of these things and how long you can spend looking for the information that applies to you, which is the reason that I've finally created this video, so that you may learn from it and benefit from it in much the same way as I do. This video's taken a lot of effort, but I feel like it was worth it. A thank you would be nice, but I don't expect anything in return. It is the internet after all, and there's lurkers everywhere. I just hope that you find it useful and I've not wasted my time. I know how important your time is, so I've tried not to waste any, and I shan't be taking up any more of your time. So with that, my name is Derek Deagle, also known as Desert Eagle Derek. Thank you for watching, and I'll see you next time.